What is entropy? Entropy is a measure of disorder or randomness in a system. Imagine your bedroom. If it's clean and everything is in place, it has low entropy. But if clothes, books, and papers are scattered everywhere, it has high entropy. So entropy tells us how much disorder, or randomness there is. The idea of entropy was introduced by German scientist Rudolf Clausius in the 19th century. He wanted to explain why some processes happen naturally, in one direction, but not the other. Let's see some everyday examples. When you mix hot water and cold water, they always become warm water. Because the heat spreads out evenly, the system becomes more random. So, entropy increases. But the reverse never happens naturally. Warm water never separates itself back into hot water. Let's see what happens when matter changes from solid to liquid, and liquid to gas. In a solid, particles are packed closely together. They can only vibrate in place and have very little freedom to move. This makes the system very ordered. So entropy of a solid is low. When a solid melts into a liquid, the particles can now move around each other. They still stay fairly close, but can slide and flow. So the system becomes more disordered, and entropy increases. When a liquid evaporates and turns into gas, particles can now move freely in all directions. They are spread out, and don't stay near each other. So the system becomes most disordered, and entropy becomes highest. That's why entropy increases when solids melt, or liquids evaporate. Do you know, my dear students, why the universe keeps moving toward more and more disorder, and how its entropy is always increasing? Second law of thermodynamics says that in any natural process, the total entropy of a system and its surroundings always increases. Every star shining, every engine running, every living thing moving, all these actions use energy. Over time, energy becomes more spread out. Systems become more disordered. So the universe moves toward higher entropy. Let's see how this works with an example. Imagine your room is very messy. Clothes are on the floor. Books are scattered everywhere. This is a high entropy state because it's very disordered. Now, you decide to clean your room. You pick up the clothes, put the books back on the shelf, and arrange everything neatly. Now your room is ordered, so its entropy decreases. But where does the energy come from? To clean your room, you need energy. You get this energy from the food you eat. Your body burns calories to move, bend, and lift things. When your body burns food, it releases heat and carbon dioxide into the air. This process increases entropy of the surroundings. Overall, entropy still increases. Can we reduce entropy? Yes, but only locally, in one part of the system. But when we do this, entropy increases somewhere else. Because we must use energy. This energy, spread heat and molecules into the air. This process increases the entropy of the surroundings. So the total entropy of the universe still increases. How can we measure entropy of system? Entropy of a system cannot be measured directly. It can be calculated by determining the heat transfer during a reversible process and dividing by the temperature. Entropy change is represented by delta S. Heat transferred by Q, that is divided by T, absolute temperature. For example, if heat of 600 joules is added reversibly to a system at 300 Kelvin, it results in increased entropy by 2 joules per Kelvin. Thanks for watching. Don't forget to like, share and subscribe to our channel for more educational content.